Hello, so today we are talking about residuals and residual plots. So this is part of the linear regression chapter in chapter 3 of your textbook, specifically section 2. So what is a residual? Well, a residual is this vertical distance between your data, what you actually see, and what you predicted, or what your least squared regression line shows. So this distance right here is my residual, and this is an example of a positive residual. A positive residual means my data point is above the least squared regression line. But up here, this would be a negative residual. This would be a positive residual. This would be a negative residual. This right here, even though it's super close to the line, it's still a negative residual because the point's below the line. In the least squares regression line, this line right here makes all these distances as small as possible. And in fact, if I add up all these positive residuals, or all the points above the line and their distance to the line, and I add those together with all these negative residuals and all these negative distances below the line, they're all going to add to 0. Because in a least squares regression line, the positives counterbalance the negatives, so this line truly is the best fit for my data. So all a residual is the difference between the observed, or your data value, or your data y, I could say, of the response, and the value predicted by the regression line. So it's what you actually see, your y, minus your y hat, or your prediction. So key point number 1 is that a residual is the observed y, so what you actually see, minus the predicted, or in formula, it would be y minus the y hat. So what we actually saw minus what your prediction line told you. So we residuals in a couple of different ways. The first example we have is an example where we're actually calculating the residual. So it says, in a statistics course, a linear regression equation was computed to predict the final exam score. So I'm predicting final exam, so this is going to be my y, from the score on the first test. So the score on the first test is my x. The equation was y hat equals 10 plus 0.9x, where y is the final exam score, and x is the score on the first test. Rachel scored an 85 on the first test, so her score on the first test is the x, so Rachel's x equals 85, and she got an 85 on the final exam. Well, the 85 on the final exam is Rachel's y value. Well, I want to know what is the value of her residual. Well, if this is the equation for the whole class, y hat equals 10 plus 0.9x, and I want to know what is Rachel's predicted score, I'm just going to say y hat, or Rachel's predicted score, equals 10 plus 0.9 times 85. And that 85 is referring to the 85 she got on her first test. Well, that gives me a y hat of 86.5, meaning based on this prediction model, she should have got an 86.5, but she actually got an 85. So when I want to calculate her residual, I know that residuals are the actual minus the predicted, or the y minus y hat. Well, she got an 85 on her actual final exam, minus the 86.5 she quote-unquote should have gotten. Well, that gives me a residual of negative 1.5. So Rachel's residual is negative 1.5, meaning her actual score of 85 is lower than what was predicted. Her residual is negative, meaning her data point is going to be below the least squared regression line. So here's another example of calculating residuals. This is a multiple choice example. So the example is actually the same. It's talking about the statistics course where y hat equals 10 plus 0.9 times x, where y is the final exam score and x is the score on the first test. But this time we're talking about Bill. So Bill scored a 90 on the first test and a 93 on the final exam. What is his residual? Well, if I think about finding his residual, I first need to find y hat. What should he have gotten, or what was predicted for him to get based on a 90 on his first test? And if I do 10 plus 0.9 times 90, I get 91. So it was predicted that he got a 91, but he actually got a 93, so his residual is y minus y hat. Well, that's 93 minus 91, which gives him a residual of 2. So B would be the correct answer. Let's break down some of these other answer choices. Answer A is the distractor, because if you flipped the order and you did y hat minus y, you would have gotten a negative 2 for his residual. But we don't want that. We want to do y minus y hat. C is another distractor because it's taking his final exam score and subtracting the score on his first test. So you have to use this formula. You have to first find y hat. You can't just subtract these two, but that's what answer C was hoping that you would do to be distracted. D is his actual final exam score, not the residual, and E is none of these. You could end up with a none of these being the correct answer. If you do this formula and your answer is not there, feel confident in choosing none of these. Another way that we could look at residuals is by looking at a residual plot and then interpreting the residuals that we see. So here's an example. Let's read kind of what it's talking about and then break down the graph. It says, here is a residual plot for the least squares regression of pack weight on body weight for 8 hikers. So pack weight, or the weight of their backpacks, is my y, and the body weight is my x. You can verify that by looking down here. Body weight is the x-axis. So my y-axis, instead of being the backpack weight, is the residuals. So these are already plotting my y minus y hat vertical distances. So if I break down, the points above the line are positive residuals, meaning that these points are where the backpack weight was more than what was predicted. The points below the line mean they predicted too high for the backpack weight, and these backpacks were lighter than predicted. So question A says one of the hikers had a residual of nearly 4 pounds. So it's referring to this residual right here. Interpret this value. Well, if I look at the x-axis at that point, that's right around 165, and that would be this backpacker right here. So he had a backpack weight, or she had a backpack weight of 35 pounds. Well, this 35 pounds is what we saw, and the residual was 4. If I think about my equation, the residual equals y minus y hat. 4 equals 35 minus y hat. And if I do the math, I get y hat equals 31. So this is saying we predicted that the backpack would weigh 31 pounds, but it actually weighed 35 pounds. So when I interpret this value, that's what I'm going to say. The residual of 4 means that for the 165-pound hiker, his/her backpack was 4 pounds heavier than predicted. We predicted that it would be 31 pounds. The actual Y value was 35, giving us a residual of 4. Another way that we could interpret residuals, given a residual plot, is being asked something like what's in B. It says, what is the residual for the hiker who weighed 131 pounds with a backpack of 29 pounds? Well, if I go to my graph and I look at where 131 pounds would be, it would be that point right there, and it's referring to this hiker right here. Well, the residual is above the line, above the 0 line, and it's right around 1. So the residual for the hiker who weighed 131 pounds is about 1. It's right around that 1 mark, and that's all you have to say for a question like this. It's helpful to annotate your graph and to show that you knew which Y or which X you were looking at and you mapped it with the Y. So I would annotate the graph if it gives it to you, but this is all you need for a complete answer. So residual plots are what we've been looking at. They plot the regression residuals against the y-axis. So the residuals are my y-axis and the x-axis stays the same. Why we do them, the whole purpose of a residual plot is to see how well a regression line fits the data, or is the data linear. So I make a residual plot to determine is the data linear, or does a regression line, a least squared line, is that a good fit for the data? Is my data linear, and does a line of best fit work for my data? Well, how do I know if it works? Here are 3 different examples of residual plots. This top one is a good residual plot. It's good, meaning the data is linear. What a good residual plot means, or what a data is linear residual plot means, is that I have points all over the line. There's no form, there's no pattern. It just looks like you took a bunch of sprinkles and just went zoom on the graph. If a graph looks like this for the residual plot, that means the data set is linear. And if you think about what this looks like on a graph, when you have a least squared regression line going through your data, you want points above and below the line kind of all scattered around the line. What you don't want is something like the bottom 2 graphs. This one right here, there's a U-shaped pattern to the data, meaning the data is curved or quote-unquote exponential. So this would be exponential data. And we don't want exponential data to have a linear model. So if you see data that looks like this, that just means the data is not linear, meaning we don't want a least squared regression line for the data. You also don't want to see something like this. In this bottom one, the data starts out looking pretty good. There's small residuals, and then all of a sudden the residuals just kind of trumpet out. This means the data is not linear. It started together, but then it kind of just becomes no clear form out here. And the residuals get pretty big, get pretty big and pretty scattered. So if residuals start off small and then get really big, that also means the data is not linear. So here's an example of kind of what this question would look like. It says a least squared regression line for predicting weights of basketball players on the basis of their heights produce the following residual plot. What does the residual plot tell you about the linear model? So the height is my x-axis, and then the residuals are my y. Well, if I look at this data, it looks kind of curved. There are points above the line, then all below the line, and then above the line again. This means the data is not going to be linear. Well, let's see which answer choice makes the most sense. Answer A says the residual plot is not an appropriate way to evaluate a linear model. Well, that's why we make residual plots, is to evaluate a linear model. So A is not correct, because this is the definition of why we make a residual plot. B says the curved pattern of the residual plot suggests that there is no association between the weight and height of basketball players. Well, this no association is going back to chi-squared, but there actually is an association. It goes down, then up. There is a curve to my graph. There is a pattern. So there is an association, meaning B's wrong. Well, then if I look at C, it says the curved pattern in the residual plot suggests that a linear model is not appropriate. So this sounds pretty good. The curved pattern suggests that the linear model is not appropriate. So this one looks like it could be correct. Let's take a look at D and E. D says there are not enough data points to draw any conclusions from the residual plot. Well, there's plenty of points on the graph. You don't have to have a set number of points. So D is wrong. And last but not least, E says the linear model is appropriate because there are roughly the same number of points above and below the horizontal line in the residual plot. Well, even though there's the same number of points above and below, I want to look at the pattern. The pattern of this line goes down, then up, which means a linear model is not appropriate. So, by process of elimination and knowing that C was a good answer when I looked at it, C is going to be the correct answer. So that's a wrap. Those were 3 great examples of how we could see residual plots in practice. Remember, residuals are the vertical distances from the data value to the prediction line, y minus y hat. And we use residuals and residual plots to determine if data is linear or not linear. This is section 3.2 in your textbook. Go there for extra examples and more visuals of different types of residual plots. Thanks, and I'll see you next time.